Okay, I think we'll get cracking and people can join us as and when. So welcome everyone to this afternoon's Reform Scotland event. My name's Chris Deeran. I'm the Director of Reform Scotland and delighted to have with us today, I think, someone whose face and name will, I'm sure, be familiar to you all. Ed Conway is the economics editor of Sky News. He's regularly found on our screens explaining the latest decision on interest rates by the Bank of England or the latest miserable growth figures. Ed and I have known each other for quite a long time now. He was a young economic. Could you mute, please, if you're not one of the participants? So Ed and I have known each other for a long time now. He was a young economics editor at the Daily Telegraph when I ran the comment pages there and wrote an excellent weekly column for us. And I think before we go into this book, it's worth saying that even then you could tell that Ed was unusual for an economist and that his sphere of interest seemed to take in more ground and be more all-encompassing than perhaps many of his peers. He was almost interested in the way that economics impacted on people and society and the history of economics as much as he was about those growth figures and interest rates. And perhaps the first sign of that in book form was his excellent work, The Summit, which tells the story of the Bretton Woods meeting and agreement. His new book, Material World, actually came out in June, so we are quite close to missing the boat on it. But as I read it, I realised that it was so good and it does something so important that I really wanted to talk to him about it for the Reform Scotland audience. Material World is, I think it's fair to say, a work of pretty vast ambition and scope. In short, it tells the story of the key materials that we've used and continue to use to build the world that we live in, which Ed identifies as six: sand, salt, iron, copper and lithium. What follows in the book are lessons in history, science, politics, economics, war and peace, the environment. What also comes through is the brilliance of human adaptation and the accompanying risks in a lot of the things that we do, and much more than that. One of Ed's conceits is to split our existence into two. So there is the ethereal world, which is the one most of us live in, which is a world of laptops and phones and cars and service sector jobs. And on the other hand, the material world, which is the one that supplies all the physical and chemical ingredients that make the ethereal world possible, and which most of us pay very little attention to. Our phone is in our hand and it does these extraordinary things. We don't think much about what goes into making that phone work the way it does. The book asks important and informed and well-investigated questions about the future, about our ability to continue digging materials out of the earth at a breakneck pace. We haven't slowed on that in any way. And whether we could even hope to cope without digging into the earth at a breakneck pace, even as we push towards net zero. It looks at what we might expect realistically in terms of net zero, despite the political promises and the scientific warnings. We know it's not an easy thing to achieve, and Ed raises some interesting points about the difficulties that maybe aren't part of the common conversation. And then he looks at where the science and the materials that he mentions, some of them are new or newer in terms of their uses than others, and where all that might take us in the decades ahead. I live in a world of words, I suppose. So let me also say that Material World is also really beautifully written. It's full of well-chosen anecdote, thrilling set pieces. Ed visits some of the most extraordinary places on the planet, both natural and man-made, and he really captures these places, the look and feel and the atmosphere of them extraordinarily well. I suspect he had a lot of fun writing this book. Or at least doing the research. I don't think the writing's ever fun. He takes what in other hands might be confusing and quite complex science and explains it in terms that are easy to understand and entertaining for the reader without ever really talking down to you. And so it was no wonder to me that the Material World has been selected by the FT and the New Statesman as a key read of 2023. So usual approach applies today. I'll have a chat with Ed and then we'll take your questions. So do send them to me using the chat function on Zoom and I'll select the most interesting. So Ed, welcome. It's very nice to see you.
Thank you. No, lovely to be here. Thank you for such a kind introduction, and coming from you, Chris, who was, one of my within journalism, you sometimes have editors and you kind of send in the copy and then you don't really hear anything else and it goes into the paper. But Chris was not that kind of editor. When I sent in the copy, I would always have feedback about what was good, what could be better, and also the bad. So, and it was always, to be honest with you, I've never said this to you, so why not say it in public? That was that was a very positive journalistic experience, because I think we want that feedback, even when it's negative. So to hear you being so generous about Material World is very meaningful. Thank you. Yeah, it's been like it is the most interesting topic I've ever looked at, and I've been lucky, in my journalistic career to be covering lots of stories, from Brexit to the Euro crisis to what we're going through at the moment to COVID, everything else, and lots traveling around the world to do it. But somehow, for some reason, this has blown everything else away. So when you say, actually, maybe it wasn't a pleasure to write, I expected this to be a bit of a chore to, because the writing is always quite tough. But actually, this was far less painful than other stuff I've written, just because there's a richness in this kind of material world, as I can call it, which I just felt very excited about telling the world more about, just because it matters to all of us, how we get stuff, how we get it out of the ground, how we make it. It matters to us. It's underappreciated, I think. So journalistically, I felt there were lots of stories here which, hadn't been told in their full glory before. And there's great political and environmental and social import to this stuff as well, because in the future, well, I think two things. I think our willingness to overlook a lot of the material basis of our existence today has in some ways kind of meant that we're kind of underappreciating the scale of what we may have to do in future to eliminate carbon emissions, because we don't really quite realize just how embedded energy and materials are in everything we do. We think that we inhabit this ethereal universe, but this conversation wouldn't be happening without an extraordinary amount of material that has come out of the ground, being turned into everything from silicon chips to fiber optics that allow us to communicate, and the continued sources of energy which are making it happen. And to some extent, we've been reminded about a lot of that recently, kind of in the course of writing the book. Obviously, what's happening in Ukraine, and also COVID and various other episodes have reminded us to some extent of the tip of the iceberg here. But the point of the book and the stuff I'm kind of banging on about is that the iceberg is enormous. It's also fascinating, and it kind of tells you a lot about the world that you might not have appreciated, because it's an unfamiliar kind of perspective through which to look at the world from the bottom up rather than the top down. So yeah, it's like I say, it's been a pleasure to explore this world, and my only hope is that more people will benefit from that kind of that vantage point as well, because I think there's something to it.
I think it's certainly true that it's impossible to come away from having read the book without a much more rounded and informed understanding of exactly that, not just what's happening out there, but how it impacts on everything that we do, even as we do try to move towards a more environmentally sustainable place. I suppose one of the first questions I should ask is, what made you choose the 6 substances, whatever that you did? Because you'd say in the book there might have been some others you could have focused on, but these 6 were the ones that really stood out.
There's definitely, I mean, like it's in a sense it's arbitrary. I mean, one of the things that defines us as a species, is the extent to which we have over time kind of ranged through different materials all across the periodic table to make the stuff that we consume. If you look at kind of modern silicon chips, and the silicon chip kind of crops up quite a lot throughout the book, just as an example of one of these things where we're taking something very simple, sand, or really actually kind of quartz that comes out of the ground, and transforming it into something extraordinary. But the quantity of different elements that go on a silicon chip has increased enormously, even over the course of the last few decades. So it used to be kind of maybe 5, 10. Now it's kind of getting on for maybe 50 or 60. And so, you could write this book and have pretty much every member of the periodic table on there. But in the end, first of all, it needed to be a book that was something you could actually handle, and so it had to kind of come down to a few. Originally I started off with 7. So originally I had wood as the seventh member of this in the conception of it. But there was just too much. There was just too much. And so maybe, you know, in future, if I ever do another book, then maybe we can do wood. Because actually wood turns out to be, again, incredibly fascinating. You know, we're all very familiar with the ancients kind of deployment of wood. There's the story of, you know, of it as the first kind of source of energy. But then there's a new kind of structural future for wood. We can make skyscrapers out of wood these days. And when we come to think about how we're going to remake chemicals, hopefully while using less in the way of fossil fuels, wood may well be an answer for that, because you can actually get certain types of chemicals from wood and from biomass. But anyway, that didn't make it. I don't know. For me, it was kind of a challenge, because normally I cover data as well as economics. So it's just a kind of another title they've given me. But there was no kind of data series where you could pick the top 5 and say these are the most important things to humankind. And there wasn't, you know, if you look through GDP statistics, a lot of the stuff that I'm banging on about in this book comes really low down. You know, steel comprises a really small fraction of GDP. So does mining, so does energy. And so if you're looking at kind of any data, there is no definitive list of what stuff really matters. So I kind of had to feel my way through by talking to as many people as possible. And that kind of got me into one of the first quandaries here, which is that within the world that I inhabit, so data and economics, that this stuff isn't really valued very highly. And that's the, I guess, the paradox of where we are at the moment. There's a story kind of relatively early on in the book, which has some relevance to Scotland. Actually, I went up to a mine in Scotland where they're mining sand, silica sand. It was kind of miles from anywhere, a place called Loch Allen. And there's a story that in 1914, we in the UK were so reliant on Germany for our optical glass, the stuff that goes into binoculars, because we used to have a pretty thriving glass industry. In fact, the UK was one of the original places where you would make glass lenses. We were kind of a world leader, as everyone likes to talk about us being a world leader. Well, back in the kind of 18th century or so, we were a world leader. 18th, 19th century, early 19th century, Britain was a world leader in making optical glass. And that was a really big deal, because back then, you know, optical glass lenses were the silicon chips of their age. You know, they were something which gave people bionic powers. They enabled you to have spectacles, so you had a workforce that could work longer. They enabled you to peer into space. And when it came to the war, it was particularly important because, you know, 1914, the First World War was kind of that first war which was fought on the basis of weapons, artillery that could go incredibly long distances. And you needed optical glass, you needed telescopes, you needed lenses, range scopes, and so on, to be able to actually hit your targets. And the UK at that point had allowed its optical industry to kind of wither away. And Germany by then was the world's biggest producer of this stuff. It was a company, Zeiss, which obviously is still a big optical producer today. And partly that was just because we just didn't value this stuff all that much, and we thought we could get cheaper optical glass from Germany, and therefore when you're looking at the kind of big spreadsheet of the UK economy, it didn't seem to matter all that much that optical glass had kind of fallen off. But then, of course, World War I happened. Suddenly people in Whitehall realized that we were importing 60% of our binoculars from Germany, and that supply suddenly came to an end. And Britain was in a very perilous place. At the start of that war, we were in a seriously dangerous place because we were sending our troops off to the trenches without binoculars. There were appeals that were launched. The government launched appeals, the army did. They asked people to hand in all of their old binoculars. The King and Queen donated 4 pairs each of opera glasses and the binoculars that they used at the race course. And that was how desperate it got, all because we just didn't value stuff that seemed relatively kind of low price and could be bought from overseas for much cheaper, all that much. It got so parlous, actually, the shortage of binoculars in the UK. You know, troops were being killed on the trenches. The Germans that was really the first war where sniper warfare became a big thing. And people were terrified about German snipers. And why were German snipers so effective? In large part because of the scopes on their guns, which we didn't have because they were made in Germany by Zeiss. And it got to such a parlous state that in 1915, a year into the war, we actually sent a spy to Switzerland to do a trade with the Germans to buy binoculars off Germany. So we were buying binoculars off the Germans in order to kill the Germans in the trenches. And the most striking thing is they said yes. And they said yes because they also had a shortage of rubber. So Britain and its colonies, the empire controlled most of the global supply of rubber, and therefore we had the stranglehold on that. They had the stranglehold on binoculars. And, you know, I think part of the underlying message of the book is that what seems not especially expensive, not especially advanced some of the time, not especially important, can all of a sudden become the difference between life and death. And, you know, it feels to some extent like we are, you know, dipping our toe, unfortunately, into that kind of experience all over again now. We may be kind of tiptoeing towards a new Cold War. We may already be in one. And as a result of that, where stuff comes out of the ground, what we do to it, where it's made, where we buy it off really matters. And our dependence on places like China, for instance, for many of the important things that we need these days, whether it's kind of raw materials or things like batteries, is greater than our reliance was on Germany in 1914. And there's a lot of stories like that in the book. Partly there's a bit of jeopardy, which obviously we journalists like. But I think a lot of it is also to say, over time, we have learnt to do amazing things. And still, the wonder of how we make concrete. I mean, concrete, I won't go on for a long time about concrete, although I could. But concrete still is one of the most extraordinary materials in the world. The science of cement, and it's something people are still studying today. You've got PhD students who are trying to understand still now, you know, kind of 200 years since Portland cement was patented. We are still trying to understand what's happening in it when it's setting. It's a magic that most people don't appreciate. So a lot of the book is kind of saying, look, this is just extraordinary. It's amazing what we can do. But part of it is just to say, because we've been undervaluing it for so long, you know, whether it's glass or whether it's silicon chips, we need to think more about it. By the way, so the mine that I mentioned, the one in Loch Allen, part of the point there is that the reason we have a sand mine, so we have it produces some of the purest sand in the world in Loch Allen, in the Morven Peninsula, that land of Morven, one of the most amazing types of sand in the world. But the only reason that place exists, the only reason there's a mine there, is because in the Second World War, we used to get all of our sands because obviously glass is melted sand. We used to get all our sand from France, just outside of Paris. Obviously, that was occupied by the Nazis. Then we needed a new source of sand, and so hence that's why we have this mine in Scotland, which is still even today producing sand that then goes down to the old Pilkington factories, and even goes to Norway, where it's turned into silicon carbide, which can be then turned into semiconductors. That is a direct consequence of something that happened, you know, back in the Second World War, and we're tracing a lot of those steps even today. But we don't think about this stuff much because no one spends much time thinking about sand, but they should, because sand is truly fascinating.
Well, I think, you know, that in the book it does come across how much of the stuff that we're using now and the places that are providing them, where we're digging them out the ground or whatever, how much of that's down to a mixture of luck or opportunity or accident as we've stumbled across it. And, you know, you talk about how this is, you know, spread across the globe, and it's fascinating just reading you obviously had a great time going to visit some of these places, and some of these, you know, marvels, some of which are natural, some of which are man-made. And I feel it would be remiss not to ask you to maybe talk about a few of the extraordinary sites that you visited, you know, things on such a vast scale that powered the planet for decades, if not more. Some of the newer places that are providing stuff, there's I think it's the lithium lake that you walk on, where it's so sharp with the
Yeah.
salt on top that you haven't worn gloves, and if you fall over, you're going to spear your hand, so you have to get off it. Just amazing things that, the German plant that the Nazis had spaced out in a way so it wouldn't be bombed. Things that most of us will never see or visit, maybe even never see photographs of or whatever. Could you maybe just talk about the ones that really caught your eye and what it was like to see them?
Yeah, and in a weird way. So I used to be, as you know, I worked with you. I used to be a kind of a newspaper reporter. And when you're working in newspaper reporting, you mostly just kind of call up somewhere. You call up a factory and ask for, how they see things at the moment. You don't tend to go to places and see stuff being made. And one of the things that gives me most pleasure in my day job is going out to various factories. Could just be on a day-to-day story, and talking to people about how they make the widgets they're making, seeing big steel presses in operation. And one of the frustrations that I have doing this day job is that when I'm making a piece about GDP and I go to some fascinating place where they're, I don't know, making tires, I want to be talking about how they make tires, And so one of the things that was most exciting about the book really was being able to do that, to go to places where stuff actually comes out of the ground. And with, for instance, semiconductors, I think that was quite so. Well, okay, now I'll start at the start. One of my favorite essays within economics, which I remember reading so early when I was starting to try and understand economics, and I should, cards on the table, and perhaps this explains why I'm a bit of an oddball economics writer. I didn't do an economics degree at university. I did later go and study economics afterwards and did a master's. But initially, when I got into journalism, I didn't have a clue. And I spent a long time just trying, very much as an outsider, to understand what was going on. And I think being an outsider gives you a kind of vantage point where you don't necessarily have to come from within and start your initial conception of economics doesn't begin with supply demand curve. That begins with just thinking about people, and that's kind of why I think hopefully I kind of look at it slightly differently. But it's the same thing with this. I wanted to go and see how stuff was made, and I'm not a physicist, I'm not an engineer, obviously I'm not any of these things that these amazing people are making, and yet I think that there's a need to try to understand some of the stuff that isn't really being met more widely by both journalism and literature. I wanted with the so iPencil was this essay that this guy called Leonard Reed wrote about. Essentially, it's written from the first person about how a pencil is made, and it's saying I'm a pencil, but and these are the different parts that go into my manufacture. You've got wood from cedar trees grown in the US. You've got rubber that comes from Indonesia. You've got zinc that's mined somewhere else. And it just explains, part by part, the process of how a pencil is made. And one of the points that the author wanted to kind of emphasize at the time, this was the 1950s, Cold War, was there is no single person who knows how to make a pencil. It is such, even for something as simple as a pencil, it's such a complex operation that no one gets it. And it is the magic of the market. And it is true. It is the absolute magic of the way that humans interact to take something that is simple and turn it into something complex, and to add value along the way, and to be able to sell that and to be able to communicate the processes of making that without ever having to really understand the whole thing. It's Adam Smith and his pin factory. And so that's the message that they were very keen to get across at the time. But when I read it, I just remember thinking, blimey, that's how you make a pencil. And I wanted to kind of do the same thing for as many different products as possible, because I think that when you're touching a smartphone, wouldn't it be nice to understand what kind of went into its production? And yet, when it came to something like a silicon chip, actually a few. There's an excellent book by Chris Miller called Chip War, which I'm sure you'll have heard of, which came out I think last year or the year before, and it's excellent about what happens within the fabrication plants where they actually make those chips. So what's happening in Taiwan when they're making those chips, and it goes through the whole history. It's a must read. However, what it doesn't really do, there's no reason why it should, what it doesn't really do is take you down all the way so you can see where that silicon that then becomes a silicon chip actually came out of the ground. And I kind of just wanted to do that. I wanted to understand when I'm touching something, where does it begin its life? What is the states that it comes out of the ground in? And so I, went on that journey from the quarry in Spain, which takes chunks out of the ground. I mean, literally, that is what becomes silicon chips. It's chunks of quartzite. It takes them away to a plant where they are thrown into an electric arc furnace alongside wood chips and coal. So coal is part of the story of how we make silicon chips, which, by the way, is also the same process whereby we make solar panels. So you're putting it in an enormous furnace with coal, you're burning it. It's like, it's like the dark ages there. And then you're taking that and then it goes through another set of processes. All the while, it's traveling around the world before it even gets to that plant in Taiwan that we've heard so much about, going through incredible processes to create literally the purest and most uniform structure pretty much in the universe. Those silicon wafers that then become silicon chips are the purest things that we can create. And yet this is doing it. A lot of people kind of moan about kind of modern technology and say, well, why is it that we've got, it was Peter Thiel that said, you gave us 160 characters, where's my flying car? The idea that we've kind of haven't delivered on, the productivity promise that we had. Well, that's not quite right, because, we have, it's just you haven't noticed it because it's there invisible inside your pocket. And I would say, a lot of people get kind of very nostalgic about things like, Concorde, these amazing engineering achievements that we haven't managed to match now, and we still have slower planes today than Concorde. Well, Concorde was extraordinary as an engineering achievement. However, what fraction of the population ever went inside Concorde? 0.001% maybe. Well, today we've got silicon chips, and in the book I kind of explain that incredibly long, amazing supply chain that obviously is way beyond a pencil. And I explain it as well as I can, but obviously it's not in any way exhaustive. It's such a detailed thing, but I do my best. They, at the final stage, as well as being turned into the purest thing on the planet, which again is extraordinary and involves kind of vaporizing it and going through various different processes. Later on, you're in the world of science fiction where you are kind of literally creating transistors that are smaller than a coronavirus, like 1,000 times smaller than a red blood cell. You're making transistors that are so small that when you're trying to send a current through them, they literally kind of come smack bang into the limits of Newtonian physics, because quantum effects start to actually take hold when you're trying to move a current around something that's measured in atoms. So that is beyond science fiction, and the process whereby they are made is even more science fiction. It's just crazy. I won't kind of spoil that, but it's extraordinary. Yet all of this to produce a chip that goes inside a smartphone that won't just be enjoyed by the 0.01% of the population who managed to travel in Concorde, but by billions. And that's for me, part of the magic of this is we are doing processes right now. We are making advances right now that are pretty unbelievable, that are kind of, you're seeing productivity in physical form going kind of one up every year. And yet I think a lot of the time we're quite oblivious of it, partly because we don't spend much time thinking about how things are made in the way that we perhaps used to do when more of us were employed within that. More of us now in the ethereal world that I inhabit, rather than in this world where we're taking stuff out of the ground and making stuff. And I just think that's rather a shame. Anyway, this didn't answer your question at all, which is like all the crazy places I've been to. I mean, there were I went to Chile. So Chile is kind of an amazing place because you have copper, which copper is sometimes it's not as sexy as lithium, because everyone wants to talk about lithium now because it's this material that's associated with the energy transition. But actually, copper is probably even more important for the energy transition. It's just that we've been mining it for thousands of years already. But it is, the oldest mined material, and yet it is the one that will get us to net zero, because you need even more copper than lithium in electric cars. You need incredible amounts of copper in electricity grids. And we need to go from right now, about 20% of our total energy comes from electricity. That needs to go to about 70% when you're relying on wind turbines and solar panels and batteries. Everything becomes electric. And without copper, we are totally screwed. And so one of the most striking experiences for me was going to what is one of the well, it is the world's biggest man-made hole. It's a mine called Chuquicamata, which is in the Atacama Desert in Chile, quite high up in kind of the foothills of the Andes. And it's crazy. It's like staring into the Grand Canyon. You know, you're looking down into it and you can barely see the bottom. And yet, this used to be a mountain. And we humans, in our desire to try to get enough copper to power the world, have created this crazy, crazy kind of deep canyon. And this place has been going for over 100 years. They were getting the copper out of there that was, you know, providing the necessary substrate in the very first electrical revolution at the start of the 20th century. And they're getting the copper out now that's going into wind turbines to try and make us, you know, energy net zero. But the thing that's most, I guess, scary about this place is not just standing on the edge and looking over at what's happening there. It's not just the degree of destruction that you need to do. And I think part of this book is unsettling because in order to fulfill our desire for stuff, like the stuff we're talking on, that has entailed some destruction on the other side of the world, and seeing that up front and up close and personal is quite overwhelming. But it's the fact, finally, that we need another 3 of those mines every year if we're going to satisfy our plans to get to net zero. So just going green involves having to create a lot more big holes. And given that we spend so little time thinking about these holes right now, that's kind of unsettling. So Chile but also in Chile they have lots of lithium, and I went to a salt flat that you mentioned the description of there. The scale though of what we need to do is extraordinary. But like I say, it's the thing about the book I hope you'll find, and I hope you found, is that it's not a tale of doom. You know, there's a lot of hope in there, but by the same token, I think there's a risk of delusion if we're not honest about what it takes right now to get the world in which we inhabit. And I just felt like learning about this stuff as an outsider, I was like, blimey, okay, so that's how the world that we take for granted comes about. I had never realized that.
And I think that sense of wonder, if this book had been written by a scientist, say, who knew a lot of this stuff or just understood the science from a starting point, the book wouldn't have that sense of wonder. And I think that's what makes it very relatable for the lay reader, if you like. So
it's worth saying there are excellent other books on pretty much all of the topics I talk about.
Yeah, but we're not here to talk about those.
No, exactly. I know. Well, buy my book, but the point is, there's a springboard, really, isn't it? Because I hope that people, you know, I just feel kind of passionately about this in a way that I've rarely done about anything I've kind of written about. I just hope that this will encourage people it'll pique their curiosity into this other material world.
Yeah, and you mentioned lithium, and everyone wanted to talk about that, as indeed I do, and will in a second. But you also mentioned copper, which, as you say, we've been using in mining for centuries, if not millennia. The other thing that grabbed me, there was just a small passage on sand, you know, the most basic of substances as we'd think about it, but of course the complexity of sand and the different types of sand, molecular, granular, or whatever, that goes into making different things. So I'll just read a little bit here. Mix sand and small stones with cement, add some water, and you have concrete, quite literally the foundational material for modern cities. Add it to gravel and bitumen, and you have asphalt, of which most roads are made. Those that aren't made of concrete, that is. Without silicon, we wouldn't be able to make the computer chips that support the modern world. Melt sand at high enough temperature with the right additives, and you make glass. Plain simple glass is, it turns out, one of the great mysteries of material science, neither liquid nor solid, with an atomic structure we still do not entirely understand. And the glass you have in your windscreen is just the beginning of it, for woven into strands and accompanied by resin, glass becomes fiberglass, the substance out of which wind turbine blades are made. Refined into pure wires, it becomes the fiber optics from which the internet is woven. Add lithium to the mix and you get strong, resilient glass. Add boron and you get something called borosilicate glass. So in a sense, this progress that we're making is based on these things that we've been using in different ways for millennia, if centuries, however you'd phrase it. But we're constantly moving and constantly, I guess, repurposing things as our understanding of the scientific world develops. And I guess that's where we come to lithium, which, as you beautifully describe it in the book, as a magical metal, one of the three primordial elements alongside hydrogen and helium created in the Big Bang. And it's utterly essential to the batteries of the present and the future. And you quote a scientist saying the universe hasn't given us anything better, which is a lovely quote. But if anything, lithium's usefulness was overlooked for a huge amount of time, wasn't it? We've only really come to realise what we can use it for and get the most out of it for in recent times.
Yeah, it's in a way it's the odd one out in these materials because the other materials, yeah, we have a long history of mining copper or indeed iron, whereas lithium, it's been around for a bit, kind of about 100 years, but it's always been a bit of a curio. It was used as a pharmaceutical, and it was used as an ingredient to try and improve the optics in certain lenses. It was used as a lubricant, so particular lubricants and oils and things have lithium in it, there's this kind of strange knock-on consequence now, the fact that everyone needs lithium for batteries, which is that the price of lubricants has gone up kind of crazily because lithium prices have gone up a lot. But yeah, we don't really have that much experience of mining this thing at scale, and that's kind of, it's both unsettling, but there's also hope there, because. Well, I went to there's two places essentially. There's two main ways of getting lithium out of the ground. One of them is you go to somewhere like the salt flats in Chile, the Salar de Atacama, or the what they've got one of them in Argentina and Bolivia as well, and you literally pump it out of the ground. And these are kind of pretty extraordinary places. The one in Atacama, it is one of the driest environments in the world. It is an ecosystem of its own kind of type that you don't really see many of around elsewhere in the world, and it has essentially to get that stuff out of the ground, we kind of pump it up. You channel all of the brine into different ponds where it evaporates over the course of about a year or so. And this one of the strange things about this book is the extent to which there are echoes throughout. So I remember I remember getting to the salt flats in Chile and seeing the way they're doing it and thinking, I've seen something like this before. And I had, because the way that they are taking the lithium brine out of the ground, they're allowing it to precipitate over time. So you've got various different salts forming, and then you've got big piles of salt that are put aside. And at the end, you get a very lithium heavy type of brine. That way of making these things is basically exactly the same as the way that the Phoenicians and the Romans, and for thousands of years, we have made salt. So that's the same way that we made salt from seawater is the way that they make lithium from the lithium brine in Chile, except that it's at this extraordinary massive scale. And the size of those ponds on the Salar de Atacama, if you look on Google Maps, you can look for the Salar de Atacama, you will see these turquoise, enormous ponds that have been carved out of the salt flats there. Well, it's a reminder of just the scale of exploitation that we are already doing in order to try to get the lithium you need for batteries these days. And what they're doing in Chile is only the fraction of it, because in Australia, they are mining even more lithium, except that they're blasting it out of the ground, because that's the second way of getting lithium. It's in hard rock. The word lithium comes from lithos, stone. It comes from hard rock, and they send it off to China because in order to turn that rock into lithium chemicals, it involves an extraordinary amount of dirty, burning chemicals, all the rest of it. And so if they send it to China, then it increases China's carbon emissions rather than increasing Australia's carbon emissions. And so, so it goes. But I guess the kind of, like I say, the paradoxical thing about lithium is we are only now learning that, how to get lithium out of the ground in vast quantities, because we never have had to do that before. And that is actually really quite unusual with most of these other things, even like cobalt and nickel, which are other big materials that you need to go into batteries. We've got quite a long history of mining those things at quite large scale because you need them as alloys for steel. With lithium, we really just don't have that. And as a result, we're having to build a whole new kind of category of mining for lithium, which has two consequences. First of all, um, while at the moment, there's a bit of hope in both of these things. While at the moment, it's certainly kind of unnerving for people that it seems to be there's loads of demand for lithium and not enough supply. Um, there are going to be loads of stories about how suddenly there's lithium everywhere. I think actually, the lithium story is going to the idea of lithium scarcity is going to disappear. It's going to evaporate. And in fact, only just the other day, there was a story about an old extinct volcano in America, which turns out may have the world's biggest resources of lithium in the world, and we never even knew about this place. And so, hurrah, it's all been solved. There'll be loads of that stuff because we just haven't been looking for lithium, and so now we are looking for it in an earnest way. We're going to find more of it. But secondly, because this is a new industry, and because we're approaching it in a way that where we are somewhat more enlightened about things like the environment, hopefully we can approach it in a way that is slightly less dirty and less carbon intensive and less destructive. But I say hopefully because I don't see much evidence of that so far. What I've seen so far is still we go about mining in much the same way that as we always go about mining. We blast stuff out of the ground with not much thought for the people whose either current or ancestral rights go back to that particular land. And there are stories aplenty in the book about people whose ancestral rights and memories have been obliterated by mines. And we do it, but while also kind of burning and spewing a lot of stuff into the environment. We're doing it right now, and that's one of the things about net zero. We are rushing towards it for obvious reasons, but does that rush towards it supersede the need to try to do that rush in a sustainable way? And at the moment, it looks like it's not really. It looks like we're just trying to get the stuff out of the ground as quickly as possible and turn it into batteries as quickly as possible, not putting much thought into like how they get recycled. There's a whole chapter in there about kind of recycling, but they're not really making many batteries right now with much thought about how you recycle them in the future. So we're not very good at recycling them. So there's still lots of stuff yet to be unwound, but I think there's hope.
Well, you say, just carrying on from that point, that there is a belief that we're sort of weaning ourselves off of the physical world, but actually it's simply not true. So I think some of the stats you give, 4 out of every $5 generated in the US can be traced back to the services sector, but pretty much everything they are based on is wholly reliant on physical infrastructure that facilitates it and the energy that powers it. You also, some more stats between 2018 and 2020. China poured more concrete than the USA had in its entire existence. China now produces more steel every 2 years than the UK's entire output since the Industrial Revolution. I mean, these are extraordinary facts, and it suggests that even if parts of the developed world are maybe slowing down some of the activity, that it's racing ahead at almost an unprecedented level in the countries that are playing catch up.
Completely. Yeah, completely. I mean, like and that's the thing. I think that's the lie that we've sold ourselves, which is that this stuff we've dematerialized. We to some extent, we have a bit within developed economies on a per capita basis, although when part of that at least is just because we no longer make as much steel here, and so we just imported most of it from China and from elsewhere. Part of it is because we have allowed most of our manufacturing industry to kind of go away, which gets to another uncomfortable point here. Like actually, so in the course of the last few months, there's a plant that I mentioned once or twice in the book, a fertilizer plant in Teesside, which it's kind of a historic place. It's been going since the 1920s. It was where Aldous Huxley, when he actually worked in chemicals for a bit, it was where he got his inspiration for Brave New World, this dystopian place with all these pipes going into the sky. Well, that was one of the first places in the UK, or the first place actually in the UK, where we made fertilizer. And making fertilizer turns out to be, we know it instinctively, but it is one of the most important achievements that humankind has ever made, has been to learn how to take the air around us and then fix the nitrogen out of the air. So take the nitrogen out of the air and turn it into a solid fertilizer that we can scatter on the ground. It turned out to be one of those goals that physicians and or physicists rather and scientists have been pursuing for so long, and then eventually managed to achieve in the Haber-Bosch process. It was a couple of German scientists and an engineer who managed to do it. And that plant has been running for kind of around about 100 years. It is being shut down now. And as a result of that, the UK will, for the first time since the invention of the Haber-Bosch process, not have any plants making nitrogen fertilizer in this country, and will be entirely reliant on imported fertilizer. There are other types of fertilizer we make a little bit of here, but nitrogen is the most important by a country mile for most of the stuff we grow. And so, that might be okay, but we are going to be more reliant on America. That's probably all right. That's where most of the ammonia will come from, but also places like North Africa, Saudi Arabia, other countries. So our reliance, I think that's significant that we take for granted this stuff because we don't really make it much here anymore. B, we kind of think we've dematerialized, but actually, no, we still really need this stuff. Like I say, the conversation here wouldn't be happening without physical stuff that you're getting out of the ground. The data that is entailed in a Zoom conversation, that data is traveling on fiber optics. Even if you may be using Wi-Fi, like I am here in our offices, but the distance it's traveling over the air is tiny compared with the distance that it's traveling physically over a fiber optic cable. The internet is strands of this fiber optic glass going around the world. And so again, we forget that. And then finally we forget, because we're kind of forgetting a lot of that stuff, we don't bat an eyelid when they shut down the last fertilizer plant in the UK. And yet, like I say, and no one had written about that. I wrote a column about it. No one had even written about that in the national press, that this had happened. And it's that fact that makes me just unsettled, because it clearly matters how we're feeding ourselves, in the UK and in Europe. And yet we seem to have just forgotten how much it matters. And there's an enormous amount of complacency about that. Which,
well, I think, Ed,
I'm
just to say, we've got about 10 minutes left, so if you do have a question for Ed, please do stick it on the chat function on Zoom, and we'll get to it. But that, it touches on another point I wanted to raise, which is that we've heard a lot, really, since the crash maybe, and the economic troubles over the last 10, 15 years, about perhaps a move away from globalization. And what comes across in your book is that simply isn't going to be possible in this regard, at least, because things are so interconnected, and we're also reliant on each other, some countries more than others. For example, you mentioned Joe Biden saying that, because of the shale revolution, America was going to be energy independent, wasn't going to do business with Saudi or reduce its business with Saudi after the Khashoggi murder. And then shortly afterwards, he was on a trip to Saudi because actually America needed access, so they needed the Saudis to produce more oil. So I guess, and you mentioned China, produces by far the majority of batteries in the world, and batteries are central to everything we're doing in terms of renewable energy and electric cars and the rest of it. So I suppose there is that sense that we are hopelessly interconnected. And the other side of it is, as we've seen with Russia in recent years, using its oil and gas deals as a kind of tool of economic warfare, that if we are in a Cold War or moving towards something that moves closer to a hot war or whatever, that these products will be used as warfare, and will have the potential to cause us gigantic problems. We're going to have to do all sorts of deals as we did with Germany in the First World War again.
Yeah, I think what's interesting, actually, just in the last kind of, obviously nothing to do with my book, but it just so happened that the things have been happening and we've been moving in this direction from a political perspective, is that only a few years ago, the UK just never spent much time thinking about supply chains. We just instinctively assumed that if you need something, you can pay the price for it and it'll turn up. We just didn't, there was no modeling of this stuff within governments. There was no thinking about it at all. So when something unexpected happened, like actually that fertilizer plant, the first time it shut itself down, we ran out of CO2 in the country. And then there was a big question over whether there was going to be enough CO2 to slaughter pigs, because you needed the CO2 to go into the stun guns that were going to slaughter the pigs. So suddenly we're going to run out of pork. Those kinds of episodes, and Ukraine, and I think to some extent the energy transition and the push for things like lithium, are starting to make people within government. I was talking to someone within government, relatively senior within government just this morning, and they were saying we are now looking at this stuff. We are now thinking about supply chains. We are now trying to map them. We are trying to understand them. And that's, I think, the beginning of quite an interesting new chapter in economics, where it's not just about price. It's not just about GDP. It's also about, I guess, what I think of as maps. So mapping reliances and dependencies across the global economy. And I think that is going to be one of the big new themes in the coming years. It's partly about industrial strategy and thinking about how you fit into those maps, but it's also just partly about understanding the resilience of them and understanding, and that comes back to understanding how things are made, what are the inputs to something that then create the silicon chip that you need, or the fertilizer you need, or the steel that you need, or the wind turbine that you're going to be building. What are the inputs into that? And up until now, I think that was kind of a black box, and it was iPencil, and we just assumed the pencil just turns up and we don't think about it. I think things are changing now, and I think we'll hear more about that. And anecdotally, a lot of people within government here, but more to the point, actually, in the US, where they're kind of more ahead on this stuff because of things like the Inflation Reduction Act and the CHIPS Act. There is an active discussion about this stuff, which to me is fascinating and quite kind of profoundly changes the complexion of economics as we know it. And so, while that's not the point of this book, that to me is interesting for the future.
It's your next book. So a couple of questions from the audience. John Edward, John, do you want to ask Ed your question? John? No? Well, I'll ask John's question for him if he's not going to join us. John says, is there a likely or possible need for a new material which we haven't properly prepared for yet? Was there
That's
any
a good question?
Futurism?
I mean, like, there's definitely, I kind of wanted to devote some of the book to, which I never really got to nanomaterials. So nanomaterials, graphene, carbon nanotubes. It's kind of really exciting because you can essentially engineer materials to have the properties that you want. And actually, there's a kind of echo again there, which is like, before plastics, generally speaking, we just had to rely on whatever geology could provide us with, or indeed biology could provide us with, in terms of the properties of something, usually the kind of physical shape of things. And you'd burn something and maybe you'd get it to have different properties, but for the most part, you couldn't architect it, you couldn't design it. Plastics was like a really big moment that allowed us to be able to do that. And then nanomaterials is kind of like the next step, where you can kind of literally design the kind of atomic structure of something. So there are hopes for that. But I mean, the thing I'm kind of nervous about with that, well, certainly the theme of the book was never about like stuff that's interesting at the margin. And I think that stuff's still just interesting on a marginal basis. But what interests me, certainly for this book, is stuff that could genuinely change civilization. And that means, with something like concrete and cement, there are amazing recipes for cement that are that bit stronger and that bit less carbon intensive, and that might well help us. Because part of the issue with cement is, A, we use incredible amounts of it, and B, it's very carbon intensive. So about 6, 7, 8%, depending on how you're talking about it, of global emissions come from that. The magic of cement is partly that it's cheap and it's everywhere and it's relatively easy to make. And the issue with things like nanomaterials is that they're expensive and making them is actually quite hard. And so they may well kind of change the world at the margin, but in terms of that scale and all of the materials I'm looking at, the whole point is you can deploy them at enormous scale and they're everywhere in our lives to change our lives. It's still going to be quite some time before that happens. But like it could be really exciting. If you've got something that could be semi-superconducting, for instance. There's a big excitement about potential room temperature superconductors recently. If we manage to crack that, I don't think they did crack it, it turns out. But if they manage to crack that, then that is just extraordinary, because a lot of our existence is electric, and if we can manage to kind of send currents around more easily, then that's just game changing. I think the only other thing I'd say, this is not entirely related to John's question, but it's also important, is a lot of the dialogue about kind of energy and about and also materials is about conservation and about kind of shrinking. But I think actually the exciting place that we could be in the future is actually about abundance of energy and abundance of materials. And I think that it's possible to envisage quite an energy abundant future, um, and quite an optimistic world. But at the moment, it doesn't seem like our politicians or our discourse is kind of there yet. It seems like it's all about, here's the problems, here's the things that we're doing wrong, here's the damage to the environment, all of which is very important. But if every single productivity leap that we've had in human history has involved deploying greater amounts of energy. And I think we're not necessarily going to have a prosperous future if we can't envisage a way of having enormous amounts of energy, because energy is just that currency that allows everyone to do that bit more. So we need more of it in the future, not less.
Well, I feel I can't let you go without asking a climate change question specifically. And you say in the book that 2050, which is the kind of crossover point that I guess the world's looking at, has little to recommend it, save that it's a nice round number, which sounds like a political project, doesn't it? And you say that no energy transition of this sort, because we've had 3 or 4 of them in the past, has been achieved so quickly. It's usually taken centuries. Each previous transition has made lives easier, as you just said. That's not necessarily going to be the case this time. So I suppose a simple question: if you were laying a bet, do you think 2050 will be achieved?
Oh gosh. I think it's going to be. I think it's going to be so much more difficult than anyone appreciates. So I mean, like, you'd have to, you'd have to be skeptical about that. And it's partly I think because people haven't been, I think, ready for what it involves. I don't think there's been honesty about it, and I don't think that's actually, maybe honesty is the wrong word. I think a lot of the politicians who signed up to it weren't aware of what it would entail. Getting to net zero is incredibly challenging. There's one example in the book. We're talking about fertilizers a bit here. So in order to make fertilizers, you use a lot of natural gas. That's the other thing, the other kind of feature here. Fertilizers, because you use that natural gas within the Haber-Bosch process in order to create hydrogen, which then allows you to take that nitrogen from the air in a high pressure reaction and bonds it to the hydrogen. So it bonds the hydrogen to the nitrogen, and then you get your kind of ammonia at the end. So you need lots of natural gas to make fertilizer. When we are consuming anything these days, any food you eat is quite literally made from fossil fuels, because there's probably some fertilizer along the way that has done it. That's leaving aside all the other kind of ways that fossil fuels has powered that process. If you wanted to replace that natural gas in the fertilizer reaction with green hydrogen, so hydrogen that's made from wind power, for instance, and then via electrolysis turned into hydrogen, you would need, just for this plant that they've just shut down in Teesside, just for that plant, which is not able to provide enough nitrogen for the UK as a whole, but is middling size. Just for that plant, you would need the entire output of the world's biggest offshore wind farm, just to provide the green hydrogen to make the fertilizer in that one plant. So it's the scale of infrastructure you need to deliver net zero, because that is part of net zero. Green hydrogen is a teeny tiny part of net zero. The scale is, I think, beyond what most people have appreciated. And the challenge, therefore, is enormous. The cost is potentially enormous as well. But the promise is great. And like I say, if this could be cast not just as trying to kind of make sacrifices, but to have an energy abundant future, then maybe you would get people a bit more behind it. But because that hasn't been spelled out, and because it hasn't been clearly enough spelled out to people that this stuff is going to be expensive, which it is, it is not cheaper. Wind power is not cheaper when you bear in mind all of the different other bits and pieces that need to go around it. But it could be in the future, and it could be much more abundant in the future once we have enough of it. Because I think those challenges haven't really been spelled out, I do worry that there's going to be a big backlash in the coming years. You're already seeing it happening in the UK, and therefore the path is going to be bumpy. But listen, we are capable of doing it. I think that's the point. We are capable of doing it. There have been many times in the past when people have said this is going to be too difficult, and actually it turns out we're doing it, whether it's inventing concrete or the Haber-Bosch process. A lot of people thought that could not be done. We did it. So we can do this stuff, and look through history. The history of the material world shows you how much we can do. But yeah, it's there's a lot of thermodynamic and kind of physics obstacles to get through before we get there.
And just one very last question, which you can give a quick answer to, relevant to Scotland. Scottish government's against nuclear power. Can you get to net zero without using nuclear power?
I don't think so. I think you need nuclear. I think you need, and I think that's the other thing. You need a broad kind of tapestry of these things. And I think that the delusional thing that a lot of people right now, you've got a lot of people banging the drum for various different sectors. It's hydrogen, it's batteries. They're going to win. This one's going to win. Solar's going to win. Wind is going to win. It's just a load of bloody nonsense. There's going to be loads of different kind of solutions all the way along the piece. And nuclear is just much more energy dense than anything else. That's the thing. When you're talking about those energy density ladders, every time from wood to coal to oil to gas, we were going up this energy ladder. Now, going down the energy ladder to rely on things like hydrogen and to rely on things like batteries, that's understandable. But it's very, very, very helpful to have something that is super energy dense. And right now, that ladder, the thing at the very top is uranium, and the certain types of uranium you need for enriched uranium for nuclear power. So, but I mean, I'm no expert on nuclear. In fact, if the book sells well enough and there's a sequel demanded, then I'm going to do uranium as one of them, and then I'll come back to you with a better answer to that.
Well, that sounds great. Well, listen, Ed,
tell everyone to buy copies.
Well, we are very much here to tell people to buy copies. I mean, I think that, the last hour will surely have encouraged those who haven't yet read the book to go and get a copy. It is well worth your while. It's an extraordinary read and eye-opening, as you've heard from Ed over the last hour. Just some extraordinary facts, and it's such an enjoyable read as well. So, listen, Ed, best of luck with the book, and thanks for your time this afternoon.
Thank you.
And we'll look forward to getting you back for Uranium and Wood, the sequel.
Thank you.
All right, all the best.